Car fires may be common to the fire service, but they should never be considered routine. Firefighters who respond to car fires may endanger themselves by underestimating the hazards, failing to take the proper safety precautions, or failing to employ proper tactics.
The materials and components used in modern automobiles have resulted in their improved performance, increased fuel economy, better crash resistance, and reduced air pollution. Unfortunately, some of these same materials and components make fighting fires in late model automobiles more difficult and dangerous than in older cars. To achieve better fuel economy, many components of late model vehicles are made of hydrocarbon-based synthetic materials that reduce vehicle weight. In a car fire, the car's plastic components add significantly to the fuel available, producing volumes of thick, toxic smoke. Plastics, however, are not the only materials the automotive industry uses to reduce vehicle weight. Used in European imports for years, magnesium parts can now be found in many American autos. Burning magnesium can go unnoticed until it contacts water, which can greatly accelerate combustion. Instead of water, hazardous materials guides strongly recommend using a Class D extinguishing agent on a magnesium fire. But this can be impractical in a car fire because the magnesium is usually already contaminated with water from hose streams. Usually, the best course of action is to avoid applying water directly on burning magnesium and to allow it to burn out. Fortunately, most auto fires involve magnesium in limited quantities, if at all, although some automobiles, such as European sports cars, use magnesium extensively in their construction. Fires involving these vehicles may require defensive tactics. Use water only on the unburned portions to keep the fire from spreading.
In the movies, you always see a burning car blowing up into a spectacular fireball when the fire reaches the fuel tank. Many firefighters believe that such explosions only happen in the movies, and they aggressively attack a fully involved auto at close range.
Serious explosions at auto fires may be relatively rare, but don't be lulled into a false sense of security. Burning cars occasionally do explode. The possibility of explosion exists whenever a vehicle is involved in a significant amount of fire. The explosion may not be impressive by Hollywood standards, but it still has the potential to maim or kill. All automobiles and trucks have components that contain liquids or gas in sealed containers that can burst, rupture, or explode when exposed to heat. Tires, batteries, drive shafts, and parts of the air conditioning system can explode violently under fire conditions. The front and rear bumpers of most late model cars are mounted on hydraulic cylinders designed to absorb the energy of a 5-mile-per-hour crash. When heated, these hydraulic cylinders can explode and become projectiles with sufficient force to shatter the knee or leg of a firefighter standing nearby. Gas-filled struts are rapidly replacing springs to assist in raising hoods, trunks, and hatchbacks. These struts are capable of exploding in 2 pieces, propelling the piston and cylinder in opposite directions.